Good afternoon. For those standing over there, maybe take a seat. We're going to get started. We have a great presentation today on play-based learning and some pretty innovative research that's been done, and these guys are going to be sharing it. So I would like to introduce Christine Lee and Randy Elam. Christine is a doctoral candidate at UCLA in the Department of Education. She manages and conducts research projects on early elementary science education at the UCLA Center for Research and Innovation in Elementary Education. Her work includes using technology to design playful learning environments for science inquiry learning. Randy is a doctoral student as well at UCLA in the Department of Information Science Studies. He's currently a fellow at the UCLA Center for Research and Innovation in Elementary Education. He's also a researcher at the Center for Research in Engineering, Media, and Performance. Without further delay, I'd like to introduce Christine, who will start us off. Or where is it, Randy? Oh, sorry, Randy. Okay.
Hi, everybody. I'm Randy, just again, and I'm going to start off explaining the body-based tracking and technology and play-based learning for science education. I'm going to start off talking and explaining about the technology portion, and then Christine's going to take over and give an example of how we use the tech in learning science. So this project is actually called Science Through Technology Enhanced Play. The project we're going to be explaining, our STEP. This was a 3-year NSF-funded project that we've been working on and we're continuing to work on now, actually. A big philosophy in our research group is role-playing. We want the students to be able to role-play and learn science through becoming part of it. In today's example, we're going to talk about bees and pollination and how kids actually learned about these structures through body-based tracking. And as you can see in this photograph, the kids are actually wearing these bee wings that they made themselves and are learning and playing at the same time. So to explain the technology that enabled the body-based tracking for this project, I need to start from the beginning, which is when we first received this grant, we really wanted a technology that would allow for students to enter a space and to have no intervention. We wanted them to have as many students at the same time interacting with the content. And we looked at a whole bunch of different systems, and we just had a really hard time finding something that was easily deployable and affordable. Because one of our long-term goals is to be able to take these sort of systems and implement them in many different learning environments, schools, museums, cultural institutions. And we couldn't find something that fit all of our requirements. So we partnered with another nonprofit and we started an open source project called OpenPtrack. And OpenPtrack allows the user or the implementer to take many cameras and network them together to track lots of people in large spaces. From the beginning, accessibility and affordability was just the foundation of really what we wanted to do. OpenPtrack runs on Ubuntu, which, if you don't know, is a Linux open source operating system. It's free to download. It's used all over the world. It's widely adopted. There's lots of documentation on how to use it, and it works on pretty much any hardware platform imaginable. And then on top of that, to allow OpenPtrack to work, we used the Point Cloud library and ROS. The Point Cloud library is a library of actually 3D models that represent people and different objects that allow computer vision to work for people and object tracking. And just to explain what computer vision is just a very basic level, a way to allow a computer to see. It's how robots see people and objects. And then the ROS is the robot operating system that works with the Point Cloud library that also allows for the person tracking that OpenPtrack is built upon. So just to reiterate, OpenPtrack is completely open source from the ground up, completely free and downloadable online. If anyone has any questions about where to get it, please just come talk to me afterwards. I'm happy to explain where it can be downloaded, and some more technical questions if anybody has them. And then just to reiterate our dedication to accessibility, we are trying our best to find the lowest cost hardware possible that the tracking technology can run on. These are just some examples of what we've been using recently. These are in NVIDIA. They're really small computers. They're a few $100s. OpenPtrack runs on them. And then you can just use the Microsoft Connect. So you can take a whole bunch of Microsoft Connects in these computers, network them together with just normal IT technology, and track lots of people in large spaces. So to explain a little bit further how OpenPtrack works, on the left-hand side of this video, you can see 4 people walking around the space. They have this line following them. The line is actually a representation of the tracking, the artifact of the tracking. Those are the tracks of the computer following person through space. And the right-hand side is actually the computer visualizing in a grid where the people are moving in the virtual environment. And then just to reiterate how many people you can track at once, this is a classroom. You're seeing now is a 3D point cloud of the students being tracked. You can see here there's lots of people being tracked at the same time. The students can just walk into the space and they're using the system. There's no intervention that allows this interactivity, this body-based interactivity to take place. You can see here that they're playing bees. There's a beehive on the ground. They're running around. They're playing with the content while learning. And that was really important to us, having lots of people, lots of students interact at the same time through the technology. We didn't want the technology to be a barrier to collaboration and learning. And then this is just an example of how the technology actually worked with the bee program. On the left-hand side, you can see the students moving around the space. And then on the right-hand side, you can see the bees actually following their movements. The kids are moving around, they're controlling the bees, they're learning about pollination. And then this is just an example of how we actually would set up one of the environments. This is a space that's off-site from the elementary school we worked with. We just took 3 Microsoft Connects. They go around the top of the classroom or the tracking environment. The students were in the back. They were just working with the teacher, setting up the day. And then in the center area is the active tracking area, which the students will use to actually interact with the content. And now Christine's going to take over and talk about the bee activity.
Hello, I'm Christine. So now that we have the technology, I'm going to show you how we used it with a whole bunch of first and second graders and how they used it to learn about pollination. So the main thing we wanted the kids to learn about, it's the importance of the bees, pollinators and plants, and the relationship and how they're interdependent, so that flowers and plants need pollinators to survive and that bees need flowers to survive. You can kind of see here, I feel like I'm really loud. You can kind of see here that we put a GoPro on a little kid, and this is him walking around in the space. You can kind of see there's a bunch of bees with his friends. And it's pretty intuitive. You go right, your bee goes right on the screen. If you run around, which happens a lot with little kids, it runs around with you. And we did this at an elementary school. And for those, I don't know if you guys know, but UCLA actually has an elementary school on campus. And we took a bunch of first and second graders. They range from 6 to 8 years old. We shuttled about 12 of them at a time with the teacher, and we did 6 lessons on pollination with them. And we looked over all of our lessons, and we found an interesting trajectory and kind of a model that all of them we found a pattern, basically. And it starts out with them going into the space, playing as a bee, which sparked really reflective scientific conversations, which then inspired them to go back into the space and play again as a bee, which led to a scientific learning conclusion. And I will go over this clearly with some video clips of kids playing. But before I do that, I am not a biologist, and I don't know if you all are, so I'm going to explain pollination a little bit to you, just so you understand what the kids are talking about and doing. So if you notice, every time a bee goes over a bunch of flowers, it's kind of growing, and the yellow ones are bunching, the blue ones are bunching, and it starts out pretty wilted. I'm going to just like that, and it grows to a bigger bunch. And how that works is if you, as a student, take your bee and hover it over to a blue flower, you pick up pollen from that blue flower. Then if you go to a different blue flower, you pollinate it because you brought pollen from the same species to that flower. And that's how the bunches are growing. The sparkly, glittery stuff is them picking up pollen. The hearts you see going up represents them picking up nectar. So you can't just take pollen from a yellow flower and bring it to a red flower and expect the red flower to grow. You have to take pollen from a yellow flower and bring it to a yellow flower in order for the yellow flowers to grow. And the idea behind this was if there's only one blue flower in the world, would we have more blue flowers? Would it reproduce? And the answer is no, because there's no other blue flower to bring pollen to. And this is a huge thing we wanted the kids to learn. So I'm going to show you, I'm going to refer back to the model I just showed you, the trajectory, the play to the discussion, the play and the conclusion. I'm going to start with play. And in this clip, this is just the kids first entering the space and just kind of figuring out what's going on and making observations.
Oh, you just pollinated.
Nathan, what happened?
You pollinated.
That flower was dead.
You pollinated it.
Hey, I'm a hero.
I know.
So the main thing I want you to take away from it is the technology. What it's really doing here is just allowing them to play that role of being a bee. Because the technology is turning them into a bee, the conversations and the observations are pretty naturally directed towards the science, right? You don't hear a teacher needing to intervene or someone needing to redirect the kids. They're just kind of naturally observing the things and observing the science of it. So after the kids had the opportunity to just kind of interact in the space with their friends, the teacher kind of took the kids towards the back of the room just to lead a basic conversation on some of the things that the kids observed. No, wrong one. Yeah. And so I just want you to notice how she's constantly referring back to the experience the kids had in the space to lead that conversation.
Ooh. Okay, what else do you notice?
Herschel's is, he has the most, he's like the one who has a lot.
Duh.
He has the most tracks.
And you guys were all getting some nectar from Herschel, and there's a ton of tracks by him. Why? What else is different about Herschel's
He's
flower?
a small flower.
He's a small flower.
This is the only yellow flower.
It's the only yellow flower. Why would that matter?
And he has a blue center.
He does have a blue center.
The red flower.
Why would it matter that he's the only yellow flower?
And small.
Okay? Think about that. What?
So once again here, they're having, it's pretty obvious the students observed a lot when they were in the interaction, and it kind of inspired them to just go ahead and list all these observations, and this kind of went on for about a good 25 minutes, and they would not let the teachers stop because they just had so many things to list that they've noticed. And what's great about that is it really kind of helps them to refine what they're seeing with the pollination and the content, and it refines kind of what they're seeing. And so towards the end of this very long discussion, they came to this big question: why is that yellow flower not pollinating? Can we get that yellow flower to pollinate? Will it ever pollinate? Is it because we didn't go to the yellow flower? Why is it not pollinating or growing? So this made them want to go back in and play again and try to answer that question. So here you're going to see the kind of play that goes on the second time around to be very different from the first time, where they're just in there and they're just shouting out observations.
I don't think we can.
Charlie says we can't pollinate because there's no other yellow flower. Who agrees with Charlie?
Me. Not me. I'm learning, guys. I'm working on my tan. Guys, I'm working on my tan. No, I'm working on my tan by the sun. See? You can see yourself. I also
Yes, Leah.
All right.
So that's them going back into the space, but you notice how them being in the space this time around is very different from the first time they were in this space. This time the tech is doing more than just turning them into a bee. They're actually in there trying to get this flower and all the flowers to pollinate. So it's much more, they're coming into this space with much more of a goal, and they're trying to investigate if this hypothesis of getting the yellow flower to pollinate, it can happen, right? So I'm just going to end and show you the final conclusion the kids made after they played a second time around.
All right, should we see if it's pollinated?
Raise your hand if you think it's been pollinated. Wait just a second, David. Raise your hand if you think it's been pollinated. Asher thinks it has. Raise your hand if you think it has not been pollinated.
It hasn't.
Only Herschel. Everybody's got to make a decision. Everybody's got to make a decision.
No, everybody just fill it up and grab that stuff.
Okay, let's see.
All right,
Let's
let's take a
see.
peek. We're going to look in the future to see if Herschel's yellow flowers were pollinated.
I don't think so. No.
Oh.
And because there's no other yellow flowers. No, because nobody has the right tracks in.
So next year, what's gonna happen?
They'll die. They're gonna die.
There's
No.
we're gonna get another yellow flower.
Because there are other yellow flowers in Africa. Okay, because and your spies in the wind.
So that was the conclusion they made. There are no other yellow flowers that will die or steal from Africa. So just to kind of wrap everything up, I'm going to have Randy come up and have some concluding remarks, and then we'll do questions.
So this seems a little bit, I think, on first glance, a little bit different than the way museums and other cultural institutions operate. There's a teacher in the room, there's facilitating, but we really believe that that's not necessarily the case for a few reasons. The first is collaborative tracking technology eliminates the need to learn and use new tools. There's no explanation. You just walk into the space and you're just interacting, right? There's no need to explain the technology. There's no misuse. And then the second way it connects is there's an opportunity to engage many visitors at the same time. Again, this technology there's no limitation necessarily at how many people can be tracked at a time. It's just, there's technical limitations, yes, but many people can interact with content concurrently. The use of large space for interactivity and co-learning and collaboration can happen. Large spaces can be activated for learning environments. And then lastly, we believe in our classroom, the teacher was actually facilitating, not teaching. Our classrooms operated more as informal learning environments. And we think the same sort of space can be created with interpreters and museum staff, just explaining and guiding content and not necessarily teaching and acting as a teacher. And that's the way that we believe that this use case is very much related to how it could be used in museums and cultural institutions. And that's it. Thank you. And I guess, is there any questions? Are we doing questions now?
Thank you.
Thanks, Christine and Randy. Do we have any questions? Yes.
I was wondering if I missed the 80 minutes of classroom times or learning content, was that before they did the activity or intermixed with interact? I guess I'm curious in terms of the technology maybe didn't need any reinforcement, but the content it seemed like it had a lot of reinforcement. I was just wondering when that came in.
Are you asking if they had outside class time learning about this?
Yeah, you had mentioned 6 lessons on pollination.
Yeah, so there were 6 different times students came into the play space. They didn't have any outside. They learned everything about pollination while just playing in the space. Nothing was done inside the classroom or outside of it.
Anything else? Okay, great. Thank you.